Hello, my name is Ricard Grieve, and it is my distinct pleasure to introduce to you the recipient of the Barringer Award for 2020. She is Professor Joanna from Imperial College London. Jo, as she's known to her colleagues, is an internationally recognised authority on the Chicxulub impact structure in matters related to the KPG impact event. Jo's first paper on Chicxulub was published in 1997 in the journal Nature, and it was based on the first marine reflection seismic profiles across Chicxulub. And Jo was a PI on that expedition. It was accompanied by a News and Views article by none other than Jay Malosh, who lauded it as a breakthrough with respect to our understanding about the morphology and character of Chicxulub. Because in fact, what Jo's paper did was for the first time categorically define the size of the impact structure. Prior to Jo's paper, there was acrimonious debate in the literature about the size of Chicxulub, with estimates ranging from 140 kilometers in diameter to as large as 300 kilometers in diameter, based on varying interpretations of potential field data. And of course, that translates to uncertainties of orders of magnitude with respect to the impact energy and the consequential environmental degradation of the Earth's biosphere. This paper by Jo has been cited over 200 times, and by any standard is a laudable debut for anyone into the field of impact studies. Following this work, Jo was PI on an ICDP funded project to drill Chicxulub onshore, and more importantly, she was a PI on a second marine reflection seismic study. This was carried out in 2005. It was a much more detailed study than the initial one and focused on the 3D character of Chicxulub and in particular the nature of the peak ring. Jo published some very significant papers based on the results of that survey, but most importantly I think it motivated her to be lead in a proposal to drill Chicxulub and focusing on drilling into the peak ring. The peak ring at Chicxulub represents a unique occurrence in the solar system. Peak rings occur on all the terrestrial planets, but the one at Chicxulub is the only one that is accessible for direct sampling. This proposal kicked back and forward between review panels for over a decade, but Jo persevered and it was finally funded, and the Chicxulub peak ring was drilled in 2016. The results of the drilling were first published in an article in Science in 2016, which focused on the formation of peak rings. This was a major breakthrough in our understanding about peak rings because at the time there was no consensus on how they formed. Basically, the information from the drilling indicated that the working hypothesis based on hydrocode modelling, which envisaged a over-heightened central peak collapsing inward and interacting with an inward collapsing transient cavity wall, was the mechanisms that formed peak rings. Since then, since 2016, Jo has published some 25 papers dealing with aspects of Chicxulub based directly or indirectly on the drilling. For example, she has published papers with her colleague Natalia Artemeva on the extent of wildfires caused by the Chicxulub event, the extent of loading of the atmosphere by climatically altering gases, and just how you do manage to get global distribution of shock quartz. I think the success of the drilling at Chicxulub, or at least the fact that it finally got founded in large part, can be traced to a workshop that Jo organized in Potsdam, which had about 45 participants from 11 nations who were interested in drilling at Chicxulub. They had diverse priorities and agendas, but Jo managed to pull it all together. And one of her initiatives was the suggestion that the participants write a paper about the Chicxulub impact structure, about the KG boundary layer, and about the KPG extinction event and how they were all interrelated. This paper was published in 2010 in Science and actually has been cited an extraordinary amount of 1,000 times since its publication. It's not that difficult to produce a paper for publication, so I tend to evaluate people on the basis of the legacy. What difference did their work make? And in Joe's case, the answer is obvious. If not for Joe, we would not know the 3D character of the Chicxulub impact event, and we would not know the nature of the peak ring at Chicxulub, which is arguably the most important impact event in the Phanerozoic history of the Earth. I think the acknowledgement of the importance of Chicxulub for Earth history is recognized now, and in fact the results of the drilling and the work that has gone on since was featured in 2019 as a runner-up of Science Breakthrough of the Year. It lost out to actually an image of a black hole. So in summary, I would say Joe's legacy is an enviable one and not one likely to be repeated. In that regard, Joe is a worthy recipient of the Barringer Award, and for that I say congratulations, Joe, and thank you for all your work.